All right. So, homework assignment. Oh, by the way, all of your assignments and quizzes are graded and up. I caught up this morning. So, we're back to even, square one, blah, blah, blah. What was I talking about? Oh, homework. So, I assume the homework assignment was trivial. So, let's look at how easy it actually was. Always looks easier when I do it. All right. And then we'll talk about that a little bit. I'm going to do it the longer way that I initially intended. So, we were supposed to write a program that counts the number of numbers between 1 and 1 million that are evenly divisible by all four of these numbers. 3, 6, 9, and 12. So the first thing I'm going to do is I'm going to create a loop that's going to go through all the numbers between 1 and a million. Start off with that. Print I is equal to 0. Or I equals 1, rather. I is a piece of paper there. Million. I is equal to I plus 1. Somebody remind me, as soon as I finish the homework, I want to talk about increment, decrement. That way I can start using that. But we don't know that yet. All right, so I equals I plus 1. And that's going to loop I through all the numbers between 1 and 1 million. Each time through, we want to ask a question. We want to say, if I mod 3, 6, 9, and 12, mod 3 is equal to 0, and I mod 6 is equal to 0, and I mod 9 is equal to 0, and I mod 12 is equal to 0. If all four of those things are true, then we want to add 1 to our count. So we have to define a variable called count. We'll start off at 0. And we'll say count is equal to count plus 1. In the end, we'll print out system.out.println count. Now, remember way back, everybody see that fine? If you want, you can hit the front lights. It's the second at the top button over there. There you go. Remember when we first started talking about Boolean expressions? What's a Boolean expression again? Any expression that boils down to a single value of true or false. I said something along the lines of don't judge a book by its cover. Sometimes really complex things actually boil down to a single value. This is one gigantic Boolean expression. Here's a Boolean expression. I mod 3 equal to 0. This is the equivalence operator, not to be confused with the assignment operator. If that's true, and this is true, and this is true, and this is true, then this entire thing will be true. If even one of these is false, the whole thing will be false. Okay? So if all four of these things are true, we're going to add 1 to our count. We're going to print out our count. So there's the correct answer, 27,777. That make sense? Now, some of you did this a little bit differently. You decided to be clever, and you figured that, oh, well, the first number that evenly is divisible by all of those is 36. So why not just ask, is I evenly divisible by 36? And you get the same number. Both of those are fine. The solution I was looking for was this one. So if you wrote the other one, it's a 0. Okay, the other one is absolutely fine, but make sure that you understand this one. Okay, I wanted you to work with compound Boolean expressions. Okay, now having said that, let me throw another little thing your way. Most beginning programmers tend to overcomplicate problems. You think that there's some really slick, short solution to something. Always solve the problems using the tools that are in your personal toolbox. Okay, don't try to invent the wheel and think there's something outside of that realm yet. Because you want to improve your skills. Eventually you'll have a lot of stuff in your toolbox you'll be able to solve problems. We would much rather have a long-winded, correct solution than a short-winded, incorrect one. Make sense? So, this problem is the long-winded version. If I is evenly divisible by that, and it's evenly divisible by that, and it's evenly divisible by that, and it's evenly divisible by that, then add 1 to count. That make sense? And that's exactly what the question asks. Okay? Now it's fine if you went and figured out what the smallest number that's evenly divisible by all of those is. But if I had made this problem more difficult, pick a bunch more random numbers, well, then you would have maybe spent a lot of time solving a math problem that a little program would have solved instantly for you by just writing a Boolean expression. Okay? So this only counts the number of numbers that are evenly divisible by all of these guys, 3, 6, 9, and 12, because I used ands between these, as opposed to using ors. So an or is going to count all numbers that are evenly divisible by any of these guys. So if at least one of these Boolean expressions is true, the whole thing will be true. Make sense? Okay, and notice no spaces between the vertical bars, no spaces between the ampersands. Now, in the case that we had this originally written, we did not need to put any parentheses in here because we had everything as an and. But if we wanted to ask the question, if it's evenly divisible by 3 and it's evenly divisible by 6 and it's evenly divisible by 9, or it's evenly divisible by 12. Now we're asking two separate questions. It's either evenly divisible by all three of these numbers, 3, 6, and 9, or it's only evenly divisible by 12. Well, or it's at least evenly divisible by 12. As long as one of these two sides is true, the whole thing will be true. Okay? So understand that that is a different question. So you can use parentheses to clarify what you're actually trying to say rather than relying on order of operation. Okay. Any questions about the homework assignment? All right. So now let's talk about the increment operator. Put them together. Okay, steal. So we have the plus plus and the minus minus operator. So if we have an integer I is equal to 5, and we say I plus plus, that's equivalent to saying I is equal to I plus 1. Plus plus I is equivalent to saying I is equal to I plus 1. I minus minus is equivalent to saying I is equal to I minus 1. Minus minus I is equivalent to saying I is equal to I minus 1. So we have two different shorthand ways of saying I is equal to I plus 1. And we have two different shorthand ways of saying I is equal to I minus 1. These are not to be confused with I plus 1. So I plus plus is not the same thing as saying I plus 1. I plus 1 boils down to the value that is 1 greater than I, but it does not change the value of I. We are not assigning a new value to I using the assignment operator like we used right here. Okay? So plus plus and minus minus physically change the value stored within I. Okay, now I'm going to trick you. So we'll say int I is equal to 0. Then we'll do a system.out.println I. And I'll steal this line for a second. Then I'm going to say I plus plus. Then we'll do system.out.println I. So what's the output of this program going to be?
0.
So I starts off as 0.
No.
This will print out as 0. Then what does this do?
It's going to keep adding numbers.
So what's the output going to be? 0 and 1. Okay. Now I'm going to say minus minus I. Actually, let's say plus plus I. What's going to print out now?
0, 1, 2.
0, 1, 2. All right. Now let's print out I plus plus. 0, 1, 2, 3. Yes, of course, it's 0, 1, 2, 2. I'm going to print out I.
0, 1, 2, 2, 3.
0, 1, 2, 2, 3. Right here, where I use the increment operator in place. So I did I plus plus and I printed it. When the plus plus comes after, the value of I is the current value of I is used for displaying. And then I is changed. Okay? As opposed to this. So it's going to be 4. When the plus plus comes before the variable, we increment first, then use the value. So plus plus I changes I immediately and produces the new value of I. I plus plus produces the current value of I and then changes I. Make sense? Realistically, you should not have to remember that. You should know it, but you shouldn't have to remember it. I would call this line and this line poor programming. Okay? You're just trying to save yourself a line of code by putting it in there like that. Now, that isn't to say there isn't sometimes a circumstance where inlining an increment like that might be beneficial. But generally speaking, when you want to increment by 1, you can do it on a line by itself, and then it doesn't matter whether you put it before or after. Because saying I plus plus here is functionally equivalent to saying plus plus I. Because I'm not actually using the value on that line. I'm just changing the value. That make sense? But it is important to know whether it comes before or after, because you will see code examples. And I'm not saying you can't do stuff like this. You certainly can. But not until you are supremely confident that you know why you're doing this. This may be a very difficult bug to find in your code. if your math is slightly off and you've inserted your increments in line somewhere. That make sense? And the minus minus works the same way. I minus minus subtracts 1 after producing the value. Minus minus I produces the new value and then, or subtracts 1 initially, then produces the new value. Okay? That make sense? So now that we did that, we can now start writing our loops with little shorthands like that. So this will print out 0 to 9. In this case, it doesn't matter if I say I plus plus or plus plus I. Choose your poison. Because I'm not actually using the value in here. Now, what if I want to add 2? Can I say plus 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 I?
Can you space those out?
Plus, like that?
Yes, not.
Let's break this down. Let's see how this resolves. When I say plus plus I, what will that boil down to? Functionally, that will change the value of I, correct? Okay, but what will what I have highlighted there actually boil down to? There's two sides here. It's what it does and then what it ultimately resolves to. What that does is sets I equal to 1 greater than it used to be. What it resolves to is the new value of I. Does that make sense? That is the value of I after we've incremented it. Because the plus plus came beforehand. So if I started off at 0 and we say plus plus I is now equal to what? It's now equal to 1. And it will boil down to the new value of I, which is 1. So what I have highlighted there is that. If I put another plus plus in front of it, plus plus 1 doesn't mean anything. Understand how we're dealing with how the value resolves? That's why the plus 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 I doesn't make any sense. Because plus plus I, the first time through here, boils down to the number 1. And plus plus 1 doesn't make sense. Because 1 is a literal. I can't change the value of 1. Okay? Make sense? That goes back to something I mentioned in a previous class about making sure you fully resolve your variables as you're walking through your code. Being able to read code and doing that with it will be very beneficial. Okay, so if I want to add 2 to I, what do I have to do? I have to say I equals I plus 2. But wait a minute. We do have a shortcut. We have something called compound operators. Compound. You know what the worst part about fantasy football is? When your team loses by like a point.
Yeah. Ooh. That happened this week.
I lost by like 2.3 points. I mean, you'd rather just get blown out, right? And I had 36 points sitting on my bench from one guy. I don't even remember. Nobody who just had a career night. Very upsetting. Okay, compound operators. So we have the plus equals operator. We have the minus equals operator. We have the time equals operator. We have the divide equals operator. And we do, in fact, have the mod equals operator. So as an example, I plus equals 2 is the same thing as saying I is equal to I plus 2. Is that a drill? Oh, it's a what? First aid kit. Man, that would have been bonus points. Show up to class with a power drill. All right, so I plus equals 2 is the same thing as saying I is equal to I plus 2. Make sense? I minus equals 2 is the same thing as saying I is equal to I minus 2. Kind of following along here? So it saves you from having to put the equal sign in there twice. Well, put the variable in there twice, I guess. So I plus equals 2 saves you from having to write I twice. So a little bit of a helper. So in here, if we don't want to write I is equal to I plus 2, we can say I plus equals 2. That's shorthand. So officially, these are called compound operators. I often refer to this as syntactic sugar. Just a little shortcut to sweeten our programming lives. Get it? Syntactic sugar. That's a good phrase. You feeling better? Missed church.
I know.
Too many video games.
I think that's what it is.
I'm pretty sure. Man, I've been dead to the world for a week and you've been worse. That's bad. Huh?
Game.
Yeah, for me it's not a game. For me, I've been ill.
I feel really bad about this.
You should.
What do you have it on?
Huh?
What system?
Me? Oh, I have it on Xbox One, but I mean, I play very sparingly, casually. Yeah, I'm good for about 30 minutes max. Then my thumbs start hurting. Yeah, I'm more of a World of Warcraft type guy. Which I had to start working on my Hunter again now that the expansion's coming out in 3 weeks. Oh, yeah. What was I talking about? Oh, okay. So everybody understand these compound operators? All right. So we've done while loops, for loops. Did we do while loops?
Touched on them. Yeah.
By touched on, did we actually write them?
No.
Are you lying?
Let's do it just to be sure.
No.
We didn't actually write them.
Okay.
Talked about writing them.
All right, then I'm about to trick you.
CSC250, the class of tricks and surprises.
Tricks and surprises.
Named the tricks and surprises with that bullet.
That's right. At least it's not wind sprints.
DOS 101 or something like that.
Huh?
Should name it DOS 101.
All right, so we're going to say int I is equal to 0. Do. Did I show you the syntax already for it?
Yes.
Okay. So do system.out.println I plus plus. We'll use one of our new guys. While I is less than 10. Semicolon. So remember, do while loops are pre-check loops. That is, we execute the body of the loop at least once before we actually check the Boolean expression. Notice that this is one of the few statements that has a semicolon at the end. Well, this is the only loop that has a semicolon as part of its syntax. That's an important distinction to make because if any of you have written one of your loops like that, where you accidentally put a semicolon at the end of your for loop there, you get a very different behavior than you would otherwise. This code happens exactly once because it's unrelated to the loop. This loop is very self-contained. It just spins through 10 times for no good reason. Okay? So if you're ever looking for a bug in your program that's acting funny, check for extra semicolons at the end of loops. So the only loop that has a semicolon as part of its syntax is the do-while loop. It's right here at the very end. And the reason for that is compiler design, how programming languages are put together. Java needs to know where the end of this statement is. The end of this statement is actually this semicolon. For a for loop, the end of the statement is the end of this statement, which isn't part of the loop's syntax. That makes sense? For a for loop, the syntax is completely self-contained right there. It's that followed by a single statement. We happen to use block statements so that we can say more than one thing inside the loop if we'd like. For a do-while loop, we are building a sandwich. It's the word do followed by a single statement, followed by the word while, open parenthesis, Boolean expression, closing parenthesis, semicolon. So this semicolon is required to let us know that we've actually hit the end of the do-while loop statement. Make sense? Okay. So what will the output of this program be? Zero to 9. What will the output of this program be? 0 to 9.
No one bring out any.
34,343.
Why?
Because it's greater than 10, so you only would have the one number.
Yeah.
Okay, why only the one number?
Because it's not less than 10.
Because it doesn't actually go through the loop, it just prints.
What'd you say?
It's a pre-check.
It's a pre-check loop.
Uh,
It's actually not a pre-check loop. It's the opposite of that. It's a post-check loop. Post-check loop. We check the Boolean expression after we execute the body of the loop at least once. So we start I off at 34,343, and we just haphazardly print it. We didn't check anything. Then we add 1 to it. We're at 34,344 now. Is 33,344 less than 10? It's not, so we're done. But we will print it that one time because it is a post-check loop. As opposed to for loops and while loops, which are pre-check loops, where we check the body of the, or we check the Boolean expression before we execute the body of the loop at least once. Make sense?
Where would you use that in like a program?
First day we introduced loops, we said each loop lends itself to a certain kind of problem, right? While loops lend themselves to problems where we don't know how many times we need to spin. An example would be like press any key to continue. For loops lend themselves to counting problems, which we do a lot of those. Do-while loops lend themselves to problems where we have to do something at least once. What was an example of something we have to do at least once?
Was it password?
Yeah, authentication. So something that's very, very common, where when you're checking your email, you have to put your username and password in it at least once. You have to submit the username and password to Gmail at least one time, and if you screwed it up, then it'll ask you again. But that would be an example of when you're authenticating. So it's one of those things where you won't use do-while loops very often, but they're actually quite common for a very small subset of problems. Something we do all the time. Okay. So going on with that example, let's just say that we ask a user to enter a number between 1 and 10. So here, let's just go through the example actually. We've used scanner in here, haven't we? So we'll go ahead and read something and figure I'll do this because as I was grading the homework, some people were saying they were struggling with the scanner. So I'll explain it just a little bit more in here. So I'm creating a variable named input of type scanner, whatever that is. We're not going to go too much into what that is, but just it's something. It's kind of like an int, but a lot more powerful. And now we're going to give it its value. It's going to be a new scanner. And when you build a scanner, you have to tell it what input stream you want it to use, whatever that means. Okay? The input stream, the only input stream we know how to use right now is the keyboard. Standard in. So that's system.in. So this says, build me a variable named input of type scanner that knows how to read in from the keyboard. That's what this guy does. So now it's built. It's like we just went to Walmart and we bought it. So now we have this tool called input that can read stuff in from the keyboard whenever we ask it to. So I might prompt the user, please enter a number between 1 and 10. And I'll just do this as a print statement instead of println. What's the difference between a print and a println? No.
Isn't one of them confined to a line?
The difference is whether or not it presses enter at the end. So println displays stuff and then hits enter to kick it down to the next line. Print displays it and leaves the cursor at the end of that line. So it'll be a prettier prompt for us. Please enter a number. We'll enter the number right at the end of that line instead of at the bottom below it in the next line. Then we'll read in our number. So that's how we can read in a single integer from the user. And we'll go ahead and spit that back out. Okay, so first line here, I create my ability to read something in from the user. I can use that as many times as I want after that because the scope of this variable is anywhere from this point on inside of the local environment defined by main. We talked about variable scope last week. Okay. Then I'm going to prompt them, enter a number between 1 and 10. Then I'm going to create a variable here called the num of type integer. And I'm going to store in it whatever's returned by this. We don't know too much about this stuff yet, but this guy will boil down to the next integer that's returned by scanner. And then we'll just spit back out to the screen whatever we read in. Please enter a number between 1 and 10. We'll put in a 5. It'll spit back out a 5. But now, what if I want to keep reading in numbers until I enter a -1? A do while or a while? If I want to keep reading in numbers and printing the number back out until I finally enter in a -1, I would do a while? Okay. Why do you think a while?
Because you said that's the one you use for any input that you don't know how many different inputs there could be.
It's correct. But what if I enter in a -1 the very first time?
Well, then it's a successful while.
But I wouldn't have asked them.
You didn't know that they were going to do it the first time.
We didn't ask them. We never prompted them. If I want to read in numbers until they finally enter a -1, do I have to read in at least one number?
Yeah, sure.
I do. So I might say do read the number in, display the number. I'm going to keep doing that as long as the num is not equal to -1. Now notice it has a problem with the num. Why is that?
So num's a variable inside. You have to put
Says the num cannot be resolved to a variable.
It's not defined yet.
outside.
I defined it right there.
So, yeah,
So
the
you're outside
outside.
the loop.
So this local environment, the environment that lives inside of here, does not extend to there. So I would need to define the num beforehand, and then I can use it in there. That makes sense? So now the scope of the num is anywhere from this point forward inside of its local environment. That is the environment that is main, because that's where it was defined. So what are we going to do? We're going to prompt them. We're going to read in the number. We're going to print out the number. If they did not enter a -1, that is, if the number they put in is something that we'll just assume that we're going to put in 0 through, or 1 through 10, or a -1. We'll just assume that we're putting in proper input. If we did not enter a -1, it'll spin back up, prompt them again. If we did enter a -1, we'll be done. I'll just go ahead and I'll system.out.println, done. Please enter a number between 1 and 10. I'll put a 1. Please enter a number between 1 and 10. I'll put a 2. I'll put a 3, a 4. Now I'll put in a -1. Make sense? Okay. Let's talk about strings. A string is an object type variable. Remember we talked about there are two different kinds of variables. We have primitive types and we have object types. What's a primitive type?
The ones that talk right to the computer.
Relationship.
It's
One-to-one relationship. That's low-level language.
You know, hold a single variable.
Okay, primitive type is a variable type built into the language that can only hold a single value. That's the extent of its abilities. It can only hold a value. So examples of our primitive types would be byte, short, int, long, float, double, char, Boolean. All right. Object types are the other type of variable. They can hold 0 or more values and potentially do more. So strings hold collections. Well, here, let's hold a collection of chars between two double quotes. As an example, double quote, hello, double quote is an example of a string. Double quote, a bunch of spaces, a question mark, a period, a bunch more spaces, double quote is also a string. Make sense? So we've already used strings before. But now we're going to actually store things as strings and do stuff with them. Defining a variable. Review. We have type var name equals value, semicolon, right? Well, if I want to define a string, the type is going to be string with a capital S. In Java, it's a capital S. In C# it's a lowercase s. In Objective-C, it's called an NS string. Java, string, capital S. Then your variable name equals the value. Now this gets a little tricky. It's why I'm often torn as to whether or not to teach strings as the first object type or not. Technically, I didn't because I showed you a scanner. All objects are defined the same way. String S is equal to new string hello, like that. This is the type. This is the variable name. This is the value. Value's on the right-hand side. So we need to talk about this value some. We have this thing called the new keyword. The new keyword has a job. I often refer to it as our real estate agent. It retrieves a memory address from the operating system for us to use to store a value. So if you want to build a house somewhere, you're going to work with a real estate agent to go and find you a plot of land that you can build that house. You can store that house. That's what the new keyword does for us in programming languages. It goes out and says, hey, I need to store a string. I need you to give me a plot of land somewhere out in memory that's not currently being used, so I'm not overwriting some other memory, that I can store my string. Okay? That's what the new keyword does. So the value over here will ultimately boil down to a memory address. Anytime you see the new keyword, you know that you are producing a memory address as a value. Okay? So, for example, right here we have a variable being defined. Type scanner. Variable name is input. Here's the value. We see the new keyword here. What should this be producing? What kind of value? Memory address. So if I print out input, it's going to print out a crazy memory address thingy. This is Java's way of representing it. Okay? This is actually not as normal of a memory address as you typically get. Let me just show you a better one real quick. I'm not going to teach you, well, I'll teach you random here in a minute. What the heck, I'll just teach it to you. So we're going to go ahead and import random. That lives in java.util, same place as scanner lives. Then if I go to print out R, which is my variable, we're going to get a memory addressy looking thing. Okay? This will make sense here in a little bit, why these two look different. All right? But for right now, just assume they both look the same. They both look like weird memory address representations of stuff. Why? Because they both had the new keyword involved in their creation. Like all objects. Go ahead.
Is new part of value?
New produces the value.
Okay, so just scanner system.
This part right here is something called a constructor.
Okay.
So this part is called a constructor. always following the new keyword will be a constructor. That is the dude who's going to build the object for me at the memory address that new found. So you go work with a real estate agent to find you a plot of land, then you work with a constructor, a contractor, to actually build the house at that plot of land. So this guy builds me the string, and we'll learn all about constructors. For now, just know they exist. Okay? So this guy builds me the string. He's called the constructor. And where is he building it? He's building it at the memory address that new returned. Ultimately, this whole thing boils down to that memory address. We are storing that memory address inside of our variable so that when we use that variable, it resolves to its memory address, which is where that house is. And then we can look at the actual house, look at the actual string. Okay? So if I wanted you guys to come to my house, I wouldn't hand you a copy of my house. I would give you the address where you can find my house. Okay? And those things are called pointers. So any place that we have a memory address, well, here, a pointer is a primitive type capable of holding a memory address. Something to point out here is in Java, many textbooks will say pointers do not exist. The reality is that in Java, almost everything is a pointer. Therefore, there is not a specific syntax for pointers. If you've programmed in C or C++ before, there is a specific syntax for pointers because you can choose to deal with things by value or by address. Java always handles it by address. Let's just say almost always. Java handles it in the most efficient way, which is almost always by address. Okay, that's why pointers get a little muddied in Java. We still talk about them quite a bit. We, as in this group. But Java textbooks rarely talk about pointers. But it's important for our foundation of understanding how languages work. All right, so I'm almost starting off with a bunch of detail, and I'm going to fill you in on some of the secrets as we go along. We're probably not going to dive too much into pointers quite yet, but we'll get a little bit into it. Okay, variable type, variable name, value. The value of any object will boil down to a memory address. From our point of view in Java, we will never actually use that memory address. We just know it exists, we just proved it by printing out our random object. Okay, like, oh, Java stored that in some memory address. Notice that it was a little bit of a funny memory address though. java.util.random@798fd984. That's because Java runs inside of a virtual machine. So it has its own virtualized version of memory. So this is actually a memory address somewhere inside of the Java virtual machine, which will then map to a physical address in your computer. Because you have that guy in the middle, the virtual machine. All right? Go ahead.
Does it create a new address every single time you run the program?
Yes. Okay. Yep, when the program ends, that memory gets marked as no longer being used, and the operating system then frees it up so it can hand it out again.
Okay.
The house is still there, but the land is marked as vacant. So if you were to walk through memory, you might find values. You might find the number 5 stored somewhere and stuff like that. But if nobody's currently pointing at it, nobody's claiming it. So the operating system would be free to hand that bucket over for somebody else to overwrite it. Okay. So again, I'm going to trick you. So every object, here we'll even put it on a slide. So I'm going to lie to you first, and then I'm going to trick you. Every object uses the new keyword when it is being defined. What we saw on our slide here, I gave an example of defining a string. Did I give an example? Yeah, right here. String s equals new string hello. So we'll go ahead. Well, here, we'll leave that other stuff in there. So we'll say string s is equal to a new string hello. Then we'll say system.out.println s. It's going to print a hello. Why not crazy memory address?
Because you defined it as a value.
Well, I defined all these other ones as values. Here's our value. This constructor, he didn't need anything for him to work. I gave this guy a value. It still printed out a crazy memory address.
But what it's holding is not, it's holding a collection of chars, not the address.
Okay, so there's some details here. These constructors, we don't know how to write them yet. At this point, we just know they exist. These are the inputs the constructor requires to do his job, to build that object. All right? Every single object that you build requires a constructor. Every single object will require the new keyword. Every single object stores a memory address. Why is it that when I print out S, it prints out the actual string rather than the address where that string lives? The reason is something called, and again, this is still backwards, so I'm going to be telling you some things, and then over the next several classes we'll be revealing. Something called polymorphism. Super scary word. All this word means is more than one method with the same name. We haven't even written methods yet. We don't even know about methods yet. We've used a couple of methods. Method. A reusable chunk of code which completes some task given 0 or more inputs. As an example, scanner has a method called nextInt. This method requires no inputs, and what does it do? It reads in the next integer from the keyboard. That's what that method does. We've seen it work. We don't know how it was written. We don't know what kind of voodoo is in there, but we've seen it function. Okay? That's an example of a method. Polymorphism means that something has more than one method with the same name. That may take a different number and or type of parameter or input. Parameter, input, same, they're synonyms. An example of this, and what I'm really showing you right now is a very special feature of Java, kind of almost a secret of Java, if you will. Here's a method called println. This method is owned by this object called out, which is owned by system. We'll talk more about that later. But this guy's a method. The println method does what? It prints something to the screen. We've seen it, right? Prints it to the screen, presses enter afterwards. We've seen it print ints. We've seen it print doubles. We've seen it print floats. We've seen it print booleans. We've seen it print chars. This println method exists several times. Every single time it's called println, but one of the versions knows how to print an int. Another version knows how to print a byte. Another version knows how to print a char, print a Boolean, print a double. Another version knows how to print an object. Now, objects are generic. Object is a generic object that only exists as the base of all other objects. So it has a very minimalistic set of skills. Only the things that every single object would need to have to exist in the language. So if we think about Java, it's this hierarchy. And the object-oriented side of Java has defined this one generic variable type at the very top called object, of which all other objects inherit from. For instance, a string has everything that a generic object has, and then a little bit more that makes it specifically a string. A scanner has everything that a generic object has, and then everything that something else has, and then everything else that something else has, and then everything else that something else has, and then everything that makes it specifically a scanner. So there's multiple inheritance there. Okay? But the point is, at the very top of that tree, we have this very, very, very generic object that knows how to do very, very little. But it's the great, 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 great grandparent of every single object that's either built into Java or that we will create. Because we get to write our own object shortly. Okay? We can create our own variable types. Now there's one version of the println method that knows how to print objects. In order for that method to work, there has to be a common method in object that every single object is guaranteed to have. Okay? So at the very top of that hierarchy, we have this generic object. And that generic object has a method within it called toString. And the default version of toString returns the string representation of the memory address associated with that object. Objects that inherit from that generic object, which all objects do, can choose to create a more appropriate version of toString that prints out something, well, that returns a string that's more meaningful to that particular object. So what we've seen here so far in class is we've seen that the random object, whose parent is probably number, whose parent is object, has chosen not to redefine that toString method. It just has inherited the generic one from its great-grandparent. So when we call println knows how to print out an object. So what it does is it automatically calls that object's toString method. So there's actually something that's being done here that we're not actually seeing. When we print out input, we're actually printing out input.toString. When we print out R, we're printing out R.toString. When we print out S, we're printing out S.toString. That's a method that all of those objects inherited from their top level parent at the top of the object hierarchy called object. Random did not rewrite that. They just took the default one. That's why random prints out with the generic memory address. Scanner did actually rewrite theirs slightly. That's why scanner looks a little different. Not a lot different, but they do have some extra stuff in here that gives some information about that particular scanner. Strings did rewrite theirs to display what we would expect to see from a string. Well, to return. ToString boils down to a string. Println displays it. Okay? So this version of println, this version of println, and this version of println are all calling the object version of println. The one that takes an object as a parameter. And what does it do? It calls that object's ToString method to print it out. Make sense? So what we're seeing as output is the result of calling ToString on each of those objects. Strings wrote theirs to be more appropriate because strings hold characters and we might want to actually see the characters rather than the memory address. Random didn't do anything special because printing out a random object really doesn't make any sense. We want to use a random object for generating random, like dice rolls and stuff like that. But displaying a random object doesn't make any sense. Okay? Scanner, again, displaying it doesn't make a whole lot of sense either. In fact, I'm not even necessarily sure why they overwrote that. In fact, they may not have for scanner. Scanner is likely 2 or 3 levels down in the hierarchy, and it could be that one of its parents, more local to it than object, overwrote it. Okay, so that's what's actually happening. There is a version of println that knows how to display objects, and it just calls whatever object you pass it .toString. Because all objects are guaranteed to have a ToString method because Java is created that way. Because that top level object has a ToString method that just prints out a memory address representation of that object. Or returns a memory address representation of that object. That make sense? So that's where polymorphism exists. Println exists multiple times. Each time it knows how to print out a different kind of value. So getting back to the new keyword, every object uses the new keyword when it is being defined. Every single time. Now I told you I was going to lie to you first. So here I'm defining a string called S. It's going to be a new string whose value is hello. And I'll print it out, and we've already seen this work. Prints out hello. Now I'll go ahead and create a string S2. And this will print out world. Hello, world. As you can see, every single object we ever create will have the new keyword in it. But wait a minute. I lied. I told you I was going to lie to you.
It's just not working out.
Java is a string-based language. That is to say, strings are very powerful in Java. If we have a value stored as a string, we can do many things with it. It's a very flexible format. So strings are incredibly important to Java. So important, in fact, that strings are almost treated like primitive types. And we've worked with primitive types up to this point. Yet this is the first time we've seen the new keyword. So primitive types do not require the new keyword. Int I equals 5. Now, isn't that 5 being stored somewhere in memory? So memory is still being sought out and used, but the new keyword isn't part of that syntax. I refer to this, again, as syntactic sugar. Java has a special syntax for strings only that allows us to create that particular kind of object without using the new keyword. That make sense? Now, there is a slight little downside, but it's only a downside if you follow poor programming practice. I'm going to teach you about that right now. So we have string s equals new string hello. We'll say string s2 equals new string hello. We'll have string s3 is equal to hello, and string s4 is equal to hello. What's the output of this program going to be? This is a very, 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 very important lesson we're about to learn. True. Think true? Okay. First of all, you correctly identified this as a Boolean expression. Okay. How do you know it's a Boolean expression?
Because you're saying that S is equal to...
It's the equivalence operator, right? Double equal sign is the equivalence operator. It's a Boolean operator. So this is a Boolean expression. It's any expression that boils down to a single value of true or false. So we're asking a question here. Is S equivalent to S2? And you said it should be true, right?
Should be true.
Okay, and of course the answer is false. All right, well, let's try that again. You've been paying attention, right?
I think I know it.
Let's try this again. S is equal to S3. Think that's going to be false? Okay, well, now you're catching on. S is equal to S4. S3 is equal to S4.
True.
Okay, why?
Because when you were doing S is equal to S4, it was trying to give you the address with the memory equal to hello.
These are all variables. These are all strings. Every one of these is a string. So S3 equal to S4 will be true. That was the only one that was true in that example.
Because you aren't using new.
It does have something to do with not using new. What would you say that is? Whenever we define a variable, we have type followed by variable name equals value. This value we've said is a memory address. We've also said that all objects are stored using a memory address. But here, using the syntactic sugar, we have omitted the new keyword, not the memory address. Memory address still gets created, but we've omitted the new keyword. If I define a variable int I is equal to 5, and I ask you what is 5 there, what would you tell me about 5? What kind of animal is that? an integer literal. So that's a literal. It's 5. That's the hard-coded value 5. This is a string literal. Hello. The new keyword is assumed there. And the very first time we run into that, and he just conked out. That was awesome. Was that actually head bob? It was like 3 bounces. That was awesome. Okay, so we have the this is the string literal. Since this is the very first time that's showing up in our program, it will get created in memory. But the next time we use that literal, it will notice that, oh, we've already stored that literal. So let's just give it the same address. Both of these variables point to the same place in memory. Up here, though, we specifically said create new memory. So even though we might already have a hello stored somewhere, it's not stored in the special syntactic sugar literal database of strings from Java. We are specifically saying, go get me some new memory. Go get me some new memory. Make sense? So S3 equal to S4 was true because both of these guys point to the same hello string literal in memory. Where each of these guys is at a brand new memory address that will not be the same because it's all part of the same program, so they're requesting new plots of land. So in these 4 lines, 3 plots of land were requested. 1 for the first line, 1 for the second line, and 1 for the third line only because the literal hello was didn't already exist in Java's string literal database. The second time, it did. So it just said S4 equal to the same pointer. That's why S3 equal to S4 was true. Now the important aspect of this, to finish up class, and everybody pay attention to this part. You should never use the double equal sign when comparing strings. Because what it's actually doing is it's comparing the memory address of them, not the contents of the string. This is not saying, is the word hello spelled the same as the word hello? This is saying, are these guys the actual same string? Okay? Somebody remind me next class, we're going to start off with how do we compare strings? What's the appropriate way to compare strings? I'll even put it in a new slide to remind myself.
His computer's at 0%.
All right, I'll see everybody on Thursday. Reminder, if any of you are interested, today is the first day of the faculty, student, staff Bible study. It starts at noon to 1, comes with free lunch. Go to the cafeteria, sign your name. Don't have to swipe or anything. It's in the terrace room.
Uptech terrace room. No homework.
I had a weird quirk.
No homework this time.
I had a weird quirk with the homework.